Hello, grade 11s. Let's do this question. This is vectors in 2 dimension. The first video is already there, so we are going to refer to it as there are more explanations there. I will also drop the link for the first video on the comments, so check out the comments for the link. Now let's focus on this question. The 5 kg or not 5 a 550 newtons force is applied horizontal on the block of mass m kg. So the mass is m kg by means of massless intensible rope. The block remains stationary. So when the block remains stationary, we know that the net force is equal to 0 newtons. Once the net force is equal to 0 newtons, we know that the object is not moving, and the diagram that we're supposed to draw is the closed vector diagram. Okay, when the angle that the rope makes with the horizontal is 30, but Tina will use the angle that is between vertical and that force, that T, or that rope. So we need to know the angle here. But what we know is that the angle here is supposed to be 90 in total, which means here is 90 degrees minus 30. No, it's not supposed to be 70. It is equal to 60 degrees. So the angle there is 60 degrees. So we have 60 degrees here. The angle that we use is always between the vertical and the rope in this case. Now we have 60 degrees. Okay. Now the first thing that you need to do when the net force is equal to 0 here, step number 1, you must draw the free body diagram. So we're going to draw the free body diagram. Then step number 2, draw the closed vector diagram. Okay, diagram. So these are the steps that we need to follow when we are about to calculate whatever that is asked in question like this one. So let's start with step number 1. Let's draw the free body diagram. The first thing that you do is to draw the force diagram. Here we have the tension, then we have the vertical force, that is Fg in this case. Then we have this one is force applied. So force applied here. So the free body diagram here to upper nansiya, we have the tension, then we have Fg, then we have force applied. Second step, you must draw the closed vector diagram. Closed vector diagram you use limit as it is. So we have force ehlayo, umgca wehlayo, sibe nomgca oya le, sibe nomgca oya le, or vertical or horizontal. Then we have 90 degrees. This one is Fg, this line is Fa, then this one is a tension force. Now we need the angles here because 90 degrees la. The angle between, if we can look here, we have umgca wehlayo, sibe nomgca oslantileyo, that is the tension. The angle there is 60 degrees. Umgca wehlayo and tension here is 60 degrees. So upper snow 60 degrees, then snow 90, therefore upper shorter ngabani with 30 degrees to make 180. Then we have a formula ka Fg, which is mg. Then we are done with that one. Then now we can go to answer the questions. The first question here says, explain why the block is stationary. The block is stationary because the net force is equal to 0. The net force or the resultant force acting on the block is equal to 0. Or we can say the force acting on the block, the forces in fact acting on the block are in equilibrium, or the forces acting on the block are balanced. So net force is equal to 0, that is the simplest one, or the forces acting on the block are at equilibrium. So that is the answer for the first question. The second question says use either calculations or construction to determine the tension. We are going to use calculations Tina sizobala to get a tension in the rope. We are going to use calculations, not the construction. We are using calculations in our case. So we are about to answer equation 2.2. Sibala ntoni? Tension. Now that the force applied is given as 550 newtons, which means we can use that force applied to get the tension. How? We use the sine rule, which says sine of angle A divided by side that is opposite to angle A is equal to sine of angle B divided by the side that is opposite to the side or opposite to angle B. So in this case, tension is opposite to angle 90, which means we are going to say sine 90 degrees divided by the side that is opposite to 90 is tension, which is equal to what we have. We have force applied. Force applied is opposite to angle 60 degrees. So we're going to say sine 60 degrees divided by force applied, which is 550. Now let's cross multiply. So cross multiply, this will multiply that, and this will multiply that one. So we have 55 times sine 90, it's sine 90 degrees times 55 or 550, which is equal to t times sine 60, it's t sine 60 degrees. Then we divide by sine 60 degrees both sides, sine 60 degrees both sides. This cancels that one. Therefore, the tension is equal to, let's press the calculator for the tension. Then the answer for the tension is equal to 635,09 newtons. Then the tension is answered now. So the question is answered. You get your 4 marks. You use sine rule because we have the closed vector diagram, so we use sine rule. Whatever it is, someone can say you must use sine theta or cos theta, but let's just use sine rule. Let's use sine rule. Then question number, how many? The last question here says calculate M, the mass. Now if we can look here, we have Fg, which will give us a mass. Fg is equal to mg. So let's first know Fg. Then sizocalculator a mass from Fg. We use the sine rule to get what? Fg. So we have 2,3. Oh, that is 2.3. Question 2.3. Let's first calculate Fg so that we will calculate the mass. Sine rule. Sine of angle A divided by side opposite to A, sine of angle B divided by the side opposite to B. So in this case, we have force applied, which is opposite to 60. So sine of angle 60 60 degrees divided by the side that is opposite to 60, which is 55. That is of 550 newtons. Sorry for that. Then sibe no sine of angle B. Then angle B now is our angle that is opposite to FG. The angle that is opposite to FG is 30. So sine of angle 30 degrees divided by B. B that is FG. Then let's cross multiply. Cross multiply. This will multiply that one and this one to that one. So sine 60 times FG, it's FG sine 60. So we have FG sine 60, which is equal to sine 30 times 550, it's 550 sine 30. 550 sine 30. Okay. Then we divide by sine 60 both sides. Sine 60 both sides. So this will cancel that. Share no FG, which is equal to. Then sicofe calculator yethu. FG is equal to 317,54 newtons. But the question said calculate the mass. Now let's go to the question. Calculate what? The mass. Now that we have FG is equal to mg. Then we take this value and substitute in under FG. So FG is 317,54, which is equal to, mass is what we are looking for. Then G is constant 9.8. Then we divide by 9.8 both sides. 9.8 both sides. This cancels that. The mass now is equal to, then we press the calculator. The mass is equal to 32,40. 32,40 kgs. That is the mass. So the question is now answered. So since we are looking for a mass, the mass is from what? FG. Therefore, we must first get FG. So this is the method that I use, but we have another method which is a component method. So we can also use the component method to answer this question. In fact, all of these questions. We can also use construction to determine the tension, even FG, but I always prefer the sine rule. I always prefer the sine rule in this case. So when we see the question like this, where the forces are in equilibrium, when the forces are in equilibrium, so I always draw the closed vector diagram. Then I use the sine rule. Then after that, I get the answers. When I see if forces like, let's say we have force that is going up and the force that is going to the right, then we have the net force there. In this case, I use Pythagoras theorem. So I have only two methods that I use. But if you want me to help you with, for example, component method, I can also do the video on that. Thank you very much.